right, today what we're going to be doing is solving quadratic equations using the quadratic formula, but this is the second day that we've been dealing with this. We've used the quadratic formula before. We know the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, and all of that is in the numerator, divided by 2a. We talked about the presence of the discriminant, b squared minus 4ac, and the negative b over 2a, how we find the x-coordinate of the vertex in standard form, and those all come together in this quadratic formula, okay? Now yesterday we talked about just using the quadratic formula, but sometimes we might have to simplify our answers even more when using the quadratic formula. So in these first couple cases, if all three terms in our answer have a common factor, we want to be sure to divide this common factor out of all three terms. Let's pretend we get x equals 6 plus or minus 2 root 5 over 8. We look at these three values. Do those three numbers have anything in common? They do. They each have a 2 in common. So what you do is you divide a 2 out of all those terms. Dividing a 2 out of 6, we get 3. Dividing a 2 out of 2, we get 1. Dividing a 2 out of 8, we get 4. So therefore, we should simplify that to x equals 3 plus or minus 1 root 5. And just like when we see 1x, we usually don't write 1x, we just write x. I'll just write 3 plus or minus root 5. And all of that is over 4. Okay? Similarly, it's also best practice to have a positive number in our denominator. So if we get a negative number in the denominator, we're going to think about dividing out a common factor of -1. Be sure to do this to every term. But when you do that to the plus or minus symbol, it doesn't really change. The plus would turn to a minus, the minus would turn to a plus, so it's really minus plus, which is the same as plus or minus. So we'll just divide that as every term. So if let's pretend we get x equals 5 plus or minus 3 root 7 over -2. We notice that there's a negative in our denominator. We should simplify this to x equals, and we want to change the -2 to a +2. So that means that the positive 5 changes to a -5. The plus or minus changes to a minus plus, which we really should write as plus or minus because there's not a minus plus symbol. 3 root 7. So our new answer is -5 plus or minus 3 root 7 over 2. Notice that there's a positive in the final answer, okay? So let's practice a couple of these. Let's solve the quadratic equations, and then we'll write in simplified radical form when we can. So our first step that we had discussed was to get one side equal to 0. So what we'd have to do is add 14x to each side. And we'd end up with 3x squared plus 14x plus 13 equals 0. Make sure that it's in standard form with the x squared term first, the x term second, and our constant last, equal to 0. Now hopefully you've got a better understanding of the quadratic formula after yesterday. So if you still need to write it out, you can. But let's try to substitute right away into the quadratic formula. The first part is -b. Well, my b is 14, so -14 plus or minus the square root of b squared minus 4ac, the discriminant that we talked about 2 days ago. So our b is 14, my a value is 3, and my c value is 13. All divided by 2a, so 2 times 3. So we talked about simplifying the three pieces. First, let's simplify negative 14. That just becomes negative 14 plus or minus the square root of. Let's find our discriminant. Remember, we did that, just a little review, by putting the whole thing in our calculator. 14 squared minus 4 times 3 times 13. And we get 40. If you don't have a calculator, remember you could do 14 squared, you could do negative 4 times 3 times 13 and deal with it. But if you have a calculator, might as well utilize it. And then 2 times 3 gives me 6. Now yesterday we also looked at, we asked to see if 40 could be simplified. Are there any perfect squares that go into 40? And there are. We could break 40 down into 4 and 10. So that means that we should rewrite our answer as negative 14 plus or minus. The square root of 4 turns into just a plain 2. And then root 10 can't be broken down further, so that stays under the radical. And then over 6. So that's kind of what we talked about doing before. But now we want to see if we have any factors in common. We look at these 3 terms and notice that they each can be divided by 2. So let's divide each of those by 2. Negative 14 would become negative 7. 2 would become 1. 6 would become 3. So therefore, our final answer would be negative 7 plus or minus 1 root 10, or just root 10. All of those terms are in the numerator, and our denominator is just 3. And that's our final answer. So really, it's just one extra step. Let's try that in example 2. First, let's get it into standard form by subtracting 8x and subtracting 1. So in standard form, this ends up being 9x squared minus 3x minus 1 equals 0. Okay? Now that we have our equation equal to 0, we can put into the quadratic formula. X equals negative b, well, my b is negative 3, so negative negative 3, plus or minus the square root of b squared minus 4ac, so negative 3 squared minus 4 times 9 times negative 1, all divided by 2a, and a is 9. So once again, let's simplify the 3 parts. First, negative negative 3 becomes a positive 3, plus or minus the square root. And now we'll put this in our calculator. Negative 3 squared minus 4 times 9 times negative 1. That gives me 45. All divided by 2 times 9, which is 18. Now we look, is 45 a perfect square? No. Are there any perfect squares that go into 45? Well, 9 does. And it's 9 times 5. That would give us 45. So that means we'll rewrite this as 3 plus or minus 3 root 5. The square root of 9 is 3, but 5 is still under the radical, and all of that over 18. Once again, let's look at these different pieces. And is there a common factor we can take out of 3, 3, and 18? Well, 3 goes into them all. 3 goes into 3 once. Again, 3 goes into 3 once. 3 goes into 18 6 times. So we should write our final answer as x equals 1 plus or minus 1 root 5, or just root 5, over 6. And there we go. just to give you more time with your homework, let's do example 4. Now, personally, I would move the negative 2x squared over to the right-hand side so it's positive, but I know we've been focusing on moving everything to the left, so I'm assuming that's what a lot of you would probably do. And so let's subtract x from both sides. And if we write it in standard form, we'd have negative 2x squared minus x plus 7 equals 0. So now let's put this into our quadratic formula. X equals negative b. My b is negative 1, okay, plus or minus the square root of b squared minus 4ac. So negative 1 squared minus 4 times negative 2 times 7 all over 2 times negative 2. Okay? And so now we'll simplify our 3 parts. Negative 1 is positive 1, plus or minus the square root. Negative 1 squared minus 4 times negative 2 times 7 gives me 57. All over negative 4. We look at the terms here, 1, 1, and the coefficients here, 1, 1, and negative 4. And there's not really anything in common. However, notice that this is a negative. And one thing we talked about was that when we have a negative, we want to divide it out so that there's a positive in our denominator. So what we'll want to do is we'll want to change these 2 signs. Again, we're really changing this sign too. I don't want you to think we're not changing every sign. It's just when you change plus or minus to minus plus, you don't see it. So what we're going to make a note is that we're going to divide a negative from all terms. So positive 1 becomes negative 1. Plus or minus root 57 becomes minus plus 57, which looks silly, so we flip it and say plus or minus root 57. And then the negative 4 becomes positive 4. And then that's really the best way to write that final answer. Okay? So that's one of the simplifications that you're going to have to do. Do exactly what we did before. Check to see if you have a perfect square. If not, if you can break it down. And then if you have common factors, divide those out. Okay. So next what we'll do is let's talk about what happens if we end up getting a perfect square as our discriminant. If we end up getting a perfect square as our discriminant, what we can do is we can take the square root. And now, since we have integers instead of radicals, we can simplify completely. So let's pretend we get x equals 7 plus or minus root 25 over 4. Well, 25 is a perfect square. Notice that the square root of 25 can turn into just plain 5. And because of that, we can add numbers like 7 and 5 and combine those as like terms. So then what we'll do is we'll split this into 2 pieces. 7 plus 5 over 4 and 7 minus 5 over 4. That takes care of the plus or minus. And then we'll simplify each of those. So 7 plus 5 over 4 would be 12 over 4, or 3. Let's see. 7 minus 5 is 2. So x is 2 over 4, or 1/2. So our final answer would be x equals 3, or x equals 1/2. Now, some of you might be saying, well, how come I have 2 answers now instead of 1? Well, you guys, we really had 2 answers here. our plus or minus here, this is really two answers. One answer is 3 plus root 5 over 4, and another answer is 3 minus root 5 over 4. Except because of the radicals, we can just write it as the plus or minus symbol. So I want you to understand that it really was two answers that we were dealing with before. It just looked like one because of the plus or minus. Okay, well, let's practice some of these. So example 5, we have 7v squared plus 6v equals 3v squared minus v plus 15. Well, I'm going to move everything to the left. That's what a lot of us do. So I'll subtract 3v squared, add v, and subtract 15. So I end up with 4v squared plus 7v minus 15 equals 0. So let's put this into the quadratic formula. I'll take negative b, so negative 7, plus or minus the square root of b squared, so 7 squared, minus 4ac, so minus 4 times negative 15, all over 2a, so 2 times 4. Let's simplify those pieces. Negative 7 can just be written without the parentheses as negative 7. Then we have plus or minus the square root of. And if we take, again, 7 squared minus 4 times negative 15, and put that in our calculator, we end up getting 289, and then over 2 times 4. So when we've used the quadratic formula, we look at this number under the square root and say, is it a perfect square? And when we look at 289, and you can use your perfect square charts if you want, we see that 289 is on that list. 289 is a perfect square. That means that we can take the square root of 289. So that means that we should have negative 7 plus or minus, and what's the square root of 289? You might know, or look at your chart and we see that it's 17. So the square root of 289 becomes 17. So negative 7 plus or minus 17 over 8. Now we're able to add and subtract these values. So we're going to then split. We're going to take negative 7 plus 17 over 8. And we're also going to take negative 7 minus 17 over 8. And let's simplify. Negative 7 plus 17 is 10. So 10 over 8. And I can simplify that fraction to 5 over 4. Negative 7 minus 17 is negative 24. Negative 24 divided by 8, well, that gives me negative 3. So that means that my two solutions are 5/4 or negative 3. And that's our final answer. So this time, when it's a perfect square, you actually have a lot more simplification to do here, okay? So let's practice another one. Example 6. First, let's get it into standard form. So we need to move everything to one side to get it equal to 0. So we can subtract 4x squared, subtract 8x. Let's see, these are like terms. I get x squared. Negative 8x doesn't have anything to combine with. And then plus 16. Okay, so now I've got x squared minus 8x plus 16 equals 0. And we'll continue to use the quadratic formula to help us simplify. Or solve, my bad. So we're going to say x equals negative b. My b is negative 8. So negative 8 plus or minus the square root of b squared. So negative 8 squared minus 4ac. So minus 4 times 1 times 16, all divided by 2a, and a is 1. Well, negative 8, we've said makes a positive 8, plus or minus the square root. And now we want to take negative 8 squared minus 4 times 1 times 16. If we put that in the calculator, it turns out we end up with 0. And 2 times 1 is 2. Now, is 0 a perfect square? It is. The square root of 0 is 0. So we can get rid of the square root sign and just say 8 plus or minus 0 over 2. Now, we talked about splitting so that we add 0 and subtract 0. But is that going to make a difference? Does it matter? 8 plus 0 is 8. 8 minus 0 is 8. It doesn't matter if we add or subtract 0. It's just going to be 8 over 2, which is 4. So this only has one solution, x equals 4. Let's make a connection to what we said about the discriminant. What was the discriminant? Wasn't 0 our discriminant? And the other day, didn't we say that if the discriminant is 0, how many real solutions do we have? Just one. And so this is a demonstration of why that is. Because if we add or subtract 0, we get the same value. So if our discriminant is 0, we only have one solution. But if our discriminant is positive, we have two solutions. Hopefully it's starting to come together. Let's do one more. Example 7. We have 2g squared equals g squared minus 3g plus 10. You can for sure move the 2g squared to the other side. I just always like to try to keep the square term, the a value, positive. And if I subtracted 2g, I'd end up with a negative. You can do that, and when you simplify, you should still get the same answer. So if you're confident, you can work forward, and you should still get the same thing at the end. But I'm going to take all of these things and move them to the left. I'm going to subtract g squared, add 3g, and subtract 10. All right, so I get g squared plus 3g minus 10, okay, equals 0. So let's put that into the quadratic formula. G equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Hopefully this is becoming very second nature for you. Oops, I didn't put my parentheses around that one. I'm a bad student, sorry. Okay, now they're there. All right, so let's simplify negative 3. I know that's going to just be negative 3 without the parentheses. And then I'll have plus or minus the square root of. And if I use my parentheses carefully and I'm cautious with the signs, we end up getting 49 as our discriminant over 2. So, is 49 a perfect square? It sure is. What's the square root of 49? Just plain 7. So, that means that we could rewrite this as negative 3 plus or minus 7 over 2. Remember, the square root of 49 is just plain 7. And now we can split because we want to take negative 3 plus 7 and divide by 2, and also negative 3 minus 7 and divide by 2. So negative 3 plus 7 is 4. 4 over 2 is 2. Negative 3 minus 7 is negative 10. Divided by 2 is negative 5. So your answer should be x equals 2 or x equals negative 5. If you had moved it to the other side and you had gotten 0 equals negative g squared minus 3g plus 10, when you got to this step, you would have gotten 3 plus or minus root 49 over negative 2. or 3 plus or minus 7 over negative 2. And again, when you split 3 plus 7 over negative 2, and then you'd have 3 minus 7 over negative 2. 3 plus 7 is 10. 10 over negative 2 is negative 5, which we got. 3 minus 7 is negative 4. Negative 4 over negative 2 is 2, which you got. So I know a couple of you had asked about what if you put it on the other side. Notice at the end of the day you get the same answer, okay? You definitely don't have to do both of those, okay? The U-try answers are on ePark. In case people worked ahead, the answer to U-try 1 is x equals 7 or x equals 1. And the answer to U-try 2 is x equals 1 plus or minus the square root of 11 over 2. Again, these are worked out on ePark for you. The answer to the answer to 3 is also on ePark. That is n equals negative 2 plus or minus root 5 over 2, okay? This hopefully is sufficient to get you guys started on that assignment. So make sure that we always start by getting one side equal to 0, put it in the quadratic formula, see what you can do to simplify the radical, cancel common factors if necessary, divide out a negative if necessary, take the square root if you can, and these are what your answers should look like. Please use your check sheets to make sure that you're doing the homework correctly. Be good. And again, these are up on ePark 2 if you need to re-watch these for an example an additional time, okay? Have a great day, guys.